Alright, another little example solving trig equations. This one's got a square in it, so we're going to look at another strategy. There's so many different types of equations, by the way. There's no way I could show you every type of thing, but I'm going to try to give you a pretty good overview today. So we've got multiple trig functions. Now they're both sine, so that's nice, that's convenient. Sine squared of x minus 2 sine x equals 0. We're going to do 0 to 2 pi again. So let me show you a strategy here where we can factor, right? So it's sometimes hard to relate to these. They don't look as obvious. If it helps, maybe you could replace this and just write x squared minus 2x equals 0. Oh, how would I solve that? Oh, I could just factor pretty easily. So similar thing here with trig functions. So let's factor sine x out. So sine x, that would leave behind sine x minus 2 equals 0, right? Well, now, just like factoring, so you can set sine equal to 0. You can set sine x minus 2 equal to 0. So if we do that, sine x equals 0, sine x equals 2, right? If I set this one equals 0 and solve. Well, sine can't equal 2. It only goes up to 1. And so that's not going to provide any valid solutions. So this is all we need to focus on. So where is sine 0? Well, right here, again, we're looking for y values. So right here at 0 degrees, or 0 radians it is. And of course over here at pi radians it is. And those would be the only two places from 0 to 2 pi. And so my two answers would be 0 and pi in this case. Again, if I want to go graph it to check myself, and I'd sure encourage you to do that. Let me just bring it up. I've already graphed it on Desmos. You can type it in just like you see. Again, it's equal to 0, so I'm looking for x-intercept. So there's one, and there's one. So again, good way, validate what you're doing, okay? Now, I guess you could just go type them into Desmos. It's so powerful, it'll show you. But we want to see the algebra behind what we're doing as well.